Hey, what's up all? Welcome to the stream. So yeah, I didn't stream on Monday night. This week is spring break for my family, so yeah, my schedule's a little off. Hey, what's up, Meshu? Thanks for joining. So yeah, before I get started, I just wanted to give a little shout out to Pyro ESP. He's been PMing me recently, and I just wanted to share this. He actually was able to. He was. I think he's the first person I know anyway to have taken my code and he actually basically grabbed the code for Vectrexy and managed to get it building, and not too difficult apparently. He said that he basically followed the same instructions that I have in my README. So if you go to my GitHub here on Vectrexy, I have these instructions. I mean, and this is for Windows. I will eventually be porting this to Linux at least. But yeah, here I given a way to get things building using VC package. Because on Windows there isn't a nice package manager, so this is one from Microsoft that allows you to install all the dependencies. So you just basically copy this line that installed the different dependencies that are needed for Vectrexy, and he basically was able to point CMake at the toolchain file that VC package creates, or basically at the VC package toolchain file, in which it is able to discover everything for find. What is it called? Find target or something? Oh, I'm good, Meshu. Thanks. Yeah, for find package. So all of these are basically going to be found if you just point it correctly at this VC package CMake file. And then he basically did this, was able to get it building, and he started looking into this question that was brought up on my last stream, which is, if you were watching, in my CPU implementation, in my reset function, I ended up having to not set the interrupt mask to 1 on reset, which is something that you're supposed to do from having read from different sources. But the reason why this didn't work, or at least the reason why I had to kind of comment this out and let it stay 0, which is the result of this assignment, is because in order to make the game 3D Mindstorm work, this 3D Mindstorm, which is a 3D imager game, it would not basically enter the interrupt that gets generated as a result of the imager, basically at a certain frequency. It keeps sending a joystick 2-button 4 press at about, let's say, 26 hertz. This interrupt would never actually, get trapped by the CPU. It would never be raised on the CPU because this interrupt mask here was set to 1, and it would need to be set to 0. Now the thing is, it really should be 1. And so one of the questions I raised was, why isn't it? The ROM surely has to be doing something to set it to 1, but what we saw was that was not the case. So Pyro, he actually took a look at that using my emulator, and he started debugging and looking through the trace of the 3D Mindstorm. And what he says here is he found the instruction that enables the interrupt. So there is an instruction that does that. It's over here. It's this ANCC 0xEF, and it's at address 51 in the game ROM. And he says, bad news is you probably have to implement the audio stuff to get there, as it looks like it's looping through sound byte raw subroutine. From the BIOS. So we did see this, that it's running through there. It's possible that it's relying on the sound byte raw subroutine to enable this. We're not sure. And he said the only way that he got out of this loop is by manipulating variable C868 just before the test instruction at 0x0E3C. The value of that variable is 80 and has to be 0 to be able to jump to E49. And then he said that at E49, if we make the jump, it checks whether the value at C80D has bit 5 set, and if it's not set, it doesn't branch back to DF7. So let me see here. C80D corresponds not to C868 here. But anyway, he says then the CPU increases the value at address C880, and if the value is 2, there I just looked ahead, there's a few JSRs in between, and I saw NCC0XEF where it clears a bit. So basically, he did some, what I often do on my stream is he used my debugger with breakpoints and, you know, watch points and kind of stepped through. He like disassembled the ROM and looked through it to see if he could find where it was enabled and try to see why don't we get there. And, you know, this is the result of what he found. So I thought that was pretty cool. It doesn't answer necessarily why it's not happening, except for maybe he's right. Maybe once we implement sound, perhaps the ROM is, you know, maybe the ROM is waiting for some interrupt that's raised by the sound in order to kind of trigger this logic that ends up enabling this other interrupt bit. So who knows? You know, I was kind of slightly curious to see if I could like repro this, but like I want to see here. He says there's a test instruction at 0E3C. So like, let's say we were to put this back to the way it should go, right? And I am going to launch 3D Mindstorm now. Let's just take a look if we can see kind of the same thing that Pyro is talking about. I may not be able to get all the way through though. I think there's a couple things that require a bit more deeper looking into, but I just want to kind of see if we get something somewhat similar. So if we just break here, I'm going to put a breakpoint on this test instruction. So 0E3C. So break on 0E3C. So let this run a little bit. So by the way, today is going to be a short stream. I'm not planning on doing my usual 2 or 2.5 whatever hours. Oh, it's just a little breakpoint. Okay, here we go. So there's a breakpoint here. So we are at 0E3C, or about to step. Okay, and so there's the test he was talking about, where we read C868. So that does go with what was written here. Exactly, manipulating variable C868 just before. He says the value of the variable is 80. That's exactly right, and it has to be 0 for it to be able to jump to there. So now the question is, you know, what writes to C868? So I'm curious to see if there's anything that writes to C868, and what would C868 be? Is that something that is just, you know, CPU, like is that just within the address space of normal RAM? Let's see here. C868, yeah. Yeah, so that basically C868. Huh. Okay. C868 is actually used by the BIOS. So let's take a look. We might actually have that mapped. 68. Oh, thanks for the follow, Dariscan. C868. There we go. Interestingly, it says it's unused, this range. Fascinating. So that's interesting. So basically this here is a kind of like a list of all the constants in memory that is used by the BIOS. Now, the way it works is that this memory map is very restrictive for the programmer. Like if we take a look, go back to the memory map here. So there's only 1 kilobyte of RAM, but in that 1 kilobyte, there's ranges in there that are kind of reserved by the BIOS. So the BIOS is like, well, if you're using BIOS functions, these are actually ranges that I'm going to be using, and pretty much everyone uses BIOS routines unless you're like you want to do your own thing. So yeah, so basically these ranges are used by the BIOS, and then you have this range here, a grand total of 874 bytes that can be used by the programmer. And that also includes the system stack, by the way, which is really not a lot of bytes. So that's it, right? Now we're looking at an address that is in this range here, C800 to C87F. We'll go back here, see C868. But interestingly, it says here in this constant, at least these are the constants for a disassembled BIOS, that there may be actually a few addresses in there that are not actually used by the BIOS. So maybe ROMs actually get a little bit more memory by taking advantage of this unused, or maybe unused, memory. There is a question mark there. So that doesn't help me. One thing we could though surmise is that maybe it is related to music and or audio, because you see all of this here, all these flags in this range have to do with music. Music, audio, you know, sounds, explosions, which are sounds. So let's assume this is not unused and it's actually used by sound, and this might actually go with what Pyro is saying, is that we might have to implement audio for this stuff to work correctly. That's totally possible. So we see here is doing a test on C868. Let's put a watch just to see if there's any code that tries to at least write to it. So just do so watch is just watch C868. So watch point was hit at 0E47. Is that something that Pyro mentioned? Whoops. So he talks about how at address 0E47. No, he doesn't mention this one, right? Oh, he does mention here 0E49. No, but that's it. That's 2 bytes after here. Interesting. Write value 80. So what just happened here? Here, store B. B has 80 in it. The value comes from up here, from 0E3A. But we ANDed B with 80. So we're looking at the top bit there. So basically B has FF in it, so it's something that comes from a little bit higher. So let's show a little bit more of our, let's go over the last 100 here. So let's see here. Oh, thanks for the follow, Salsa Nerd. Yeah, so let's see here. We got here the B, the FF here. So, okay, this is a return, so this comes from a subroutine. So I'm looking for where B got its FF. Looks like it comes from here. Load B with the value that's at D001. Aha! D001. So that's interesting. This is a read. If I'm not mistaken, that's a read from the DAC in the VIA. So see, the VIA starts at D000, and then basically D001 is port A. So port A is very interesting. See, port A is basically mapped. It's a memory map register that is mapped to the DAC on the VIA, so the digital to analog converter. And this DAC is both used as input and output. So I wouldn't be surprised that actually here, this code might be, like Pyro was saying, related to trying to read a value back that would be written to the DAC, maybe from audio. So far we don't really have any code that relies on reading from the DAC. So far all our code relies on writing to the DAC. So let's see, am I right about that? Digital input. Well, no, that's not quite true. There is the joystick button state. That's true. Okay, so yes, that's right. Here we go. So basically when we read from port A, from that D001 address, right now, what we're doing is under certain conditions, right? We're seeing if we're not, if the sound direction is not set. So this here, the sound B-dur here. Basically, I think this bit determines on port B. What is this again? Mux. Okay, so this bit here has something to do with audio and the direction that like whether I guess we're reading or writing to the audio chip. So if it's not set, I don't know what it means. Like I guess it means if we're not reading from it, I guess. And sound BC1 is enabled. I forget, but this basically means we are we want to read PSG's port A, not the Vias DAX. It's probably wrong. Anyway, we want to read the inputs for the button states, but that's probably not what's happening right now. So like if I set a breakpoint here, for example, let's see here. How do we want to get back to this load B right there. So 0F24. So let's put a breakpoint on that. So we are 0F24. So we're about to step. I'm just going to put a little breakpoint in my code. Hopefully we'll see what happens. We'll step, and here we are. So port A has a value of 0xe. Oops. Looks like this in binary. And I'm assuming we're not going to step in here. Oh, we are. Interesting. But the data direction is 0, so actually we are reading the joystick button state. Ah, that's fascinating. Joystick button state. And we're looking to see if the top bit is set. Huh. Okay, that's really interesting, actually. But this comes back. Doesn't this come back? Yes, of course. Okay, so this comes back to the fact that we're actually waiting for joystick 2 button 4, which would be that top bit to be set. Yeah. All right. So let's see here. So okay, I think I know what's going on here. Let me just run this for 1 second. Let me look at my breakpoints again. What is it called? It's oh yeah, info reg. That's it. No, not info reg. Info break. I forget my own commands here. So we have an instruction 1 on 0E3C, 0F24, and C868. That's a write to there. Okay, so let me disable 0 and disable 2. Continue. 0F24. So 0F24. Right, so this is where we read. Okay, so this is what we're going to do. We're going to read here, step, decrement, load A, store A, and B. So here, this test here. We're going to say branch if not equal to 0E44. Otherwise, we would have reached 0E4A, I guess. No, let's see. It would be 4A, 4B if we had not taken this branch. So that's what we're waiting for. We're waiting. Okay, so what's happening is we're checking if the top bit is set and if the top bit is cleared, actually. And if the top bit is cleared, it means that the imager sent its button press for joystick 2 button 4. So what we can do is, to see if I'm right, let's put a breakpoint on 0E. What we're waiting for is to hit 0E4B. And I know it's that because it would be the instruction following this one. This one is a 2-byte instruction. We see it here. So that brings us to 4A, 4B. All right. And info break. So that's what we want is 0E4B. So let's disable 2 here. All right. So now we're waiting, right? We're not hitting it. But, whoops. But I have some code that we wrote last time. SDL engine. And there's hack simulate 3D imager. Where what this code does is that at a frequency of 26 hertz, it's going to send a button press on joystick 2 button 4 or whatever. Yeah, joystick 2 button 4. So let's enable this. This is kind of required. This is us simulating that we have a 3D imager attached. And hopefully we'll hit our breakpoint. And we hit our breakpoint. Awesome. So that works. So I think maybe what Pyro was actually stuck on was the fact that he didn't have this code. So Pyro, if you're watching this stream later on, the reason why you were stuck in that loop was because you didn't have this code here. I finally pushed this hack, and you're gonna have to turn it on yourself locally. It's off by default because I don't want to be spamming button 4 there, but this has to be enabled at some point for it to think there's a 3D imager. And this is the thing that like is constantly pulsing that button at this rate, and it's using that to get the interrupt and run the interrupt service routine to do the render. And it's doing it at about half the frequency that you usually want for a frame. Like a normal frame on the Vectrex, we typically are running at around 50 hertz, and here it's something like 26, 25 hertz. So basically, I think the idea there is to render kind of like the even and odd frames. So, you know, twice per game frame, if you will. So I think that's what this is about. And yeah, so this is required to get there. Now, as for this instruction at 51, zero 51. I mean, I don't think we're gonna reach that instruction, right? Okay, we just reached this one again. Oh, and here we are. We are at 0051. So this is the instruction that supposedly, probably that enables the interrupt. Let's see, where are we? So this should enable the interrupt. Let's see. And CC EF. So we do reach this one. And look at that. I went from high to low. Okay, that's kind of surprising. It went from 1 to 0. Well, that's great. So why, if that's true, you see here this I here? This is what we wanted. We wanted it to go low. Oh, and then it went back up high. Is that because there was an interrupt? Okay, let me just disable this one now. This one here at 0. And let's just see. Oh, it works. Okay, that's very interesting. The only thing I can think Because definitely, if, you know, last time we were working on this, definitely having this be 1, it wasn't working. And I think it might be because this condition where we are kind of hammering the button press 4 was something that I was enabling right from the start. And it's possible we had some weird behavior related to that. It's possible that setting this, like sending these inputs right away from the very beginning is causing intermittent problems. Sometimes it works, sometimes I get weird results. And it might be that we need to wait at some point. Now, I don't know if the Vectrex communicates with the imager, how it knows when to start spinning. There's a bit of stuff missing for me there. Like right now, if we start like this, it might or might not work. So this time it worked. Okay, some couple of weird glitches there. I'm resetting and I'm starting again just to see. See, here we go. Oh, and now, okay, eventually it starts. So maybe it does eventually start, but I definitely remember it like seemingly staying stuck in a loop and requiring me to initialize that to 0, but now I'm not sure. Maybe it was another problem and it ended up being fixed. It seems to go through. Although, see, it's like way more. It's kind of erratic in the way it's acting right now. Whereas, let's say we start this by like false here, and we turn it on at one point. Hey, Raptor. Is it possible that the actual imager takes a bit of time to spin up? It is possible, and or reach a stable frequency. Yeah, that sounds totally viable. Yeah, that must be one of the things. Though I suppose if you reset the game and the imager is already spinning, then the time before it starts signaling reliably will be shorter. That's true. But basically right now it looks like we don't really have a problem. So I turn it on now and disable my breakpoint. So I don't know. I guess it was working. It seems to be behaving exactly the same way. I don't know. I mean, there's clearly some glitches going on here, and I'm not sure exactly what it is, but you know what? I'm satisfied with this. Basically, I think we can get rid of this code now. That this to do, we can go back to resetting it properly to 1 because it looks to me like everything's working. So yeah, I guess that's good news. So I don't know, like it must be a red herring. I was probably chasing this bug, but it was related to another bug, and I must have, and you know, maybe when I started doing this, you know, pushing at a certain rate, it turned out I had already disabled this to 0, and I didn't need to or something. I probably approached it from the wrong direction. First thinking this had to be 0 for it to work, then doing this part here of sending inputs, but not bringing this one back. That's probably what happened. But it looks like we don't need to do that, so that's good. That's good news. All right, so let's put this back. When did I even do this? All right. CPU. Properly reset CC, or what do I say? Properly set interrupt mask bit to 1. On reset. So So you know what? Just give me a second. I'm just gonna get some water. I'll be right back. All right. Okay, so now I'm trying to remember what it was that we stopped on last time, and if I recall, we were trying to get Bedlam to work, because Bedlam was like another one of those games. Let me see here. That needed RTI to work. Is that right? Let me see here. Maybe not. Bedlam. It was CWAI, so we implemented this last time, didn't we? Along with RTI. So let's see again how far we get with Bedlam. I think we didn't get all the way Bedlam here. Let's see. That did not work. Why would launch 3D Mindstorm? Found overlay for Bedlam. Okay, that was just weird. Oh, that's right. We got here. Oh. Holy crap, it's working. That is odd. Okay, so tonight basically things just work. I seriously didn't do anything since last stream, and tonight this game was not working, and I didn't change anything since last stream, and now it's working. Super weird. Last time what happened was the map loaded up, and then we just had a little dot in the middle of the screen. I'm gonna go look at my log here, see if I did anything weird to have fixed it. So this is what we did last time. It was, I committed these tonight, but we worked on this last time. This was the RTI that we implemented. Because Bedlam actually, not only did it need CWAI, but it uses RTI to come back from their interrupt service routine. So we implemented this, but then after that we saw that it was, you know, giving that dot. Could it be related to this? What we just fixed here? I wonder. I have to try. Because otherwise I just think I'm going crazy. Let's put back to 0 just to see. And let's configure it to run Bedlam. What just happened? Oh, okay. My resource monitor was open on my other desktop. let's see here. There we go. My computer is going very slow right now, so I just want to see what's using up my CPU. Okay, looks like we're okay. Alright, so let's run Bedlam. And OBS is totally crunching right now. It's like using 50-something% of my CPU. See this? So it is that. Oh wow, that's so interesting. Wow, okay, so the very fact that the interrupt mask wasn't being reset to 1 here was crucial for Bedlam to work. Whoops. Fascinating. Here, let me plug my controller. Alright. Yeah, there we go. So there we actually fixed Bedlam by correctly resetting the interrupt mask to 1. So I guess something was going on, probably a timing related thing where, you know, Bedlam goes and sets it to 0 when it's ready to receive interrupts, but then its interrupt service routine was being invoked much earlier because of the fact that the interrupt mask wasn't at 1. And so yeah, that must have caused, you know, it to run its ISR much too early when things were not correctly set up, and then everything didn't work. So yeah, that makes sense actually. So I'm glad that putting it back this way happened to fix Bedlam. It's kind of good. That's a cool game. The star doesn't quite line up with the overlay, so that might be some kind of offset issue on my end. Ah. Man. It's gotta be like so precise. End. Alright, so that's cool. So Bedlam works. So I'll say great. So I'm guessing all the other ones will work too. Spinner, hack. Let's see. Oh, I'm not turning on this one. Unless I need to use... No. Alright, for some reason the analog input's not seeming to have any effect here. Unless spinner hack means something, I don't know. Huh. Oh, so this spinner hack is not working. So there's definitely something going on with timing in here. See, after we died and we started again, we got that white dot here. Oh! It seems related to the second controller, like you're supposed to use the second controller maybe to turn? Guess I should read about what these hacks are supposed to represent. And see, then when I start again, I got the black dot, the white dot problem again. The thing is, I never know, you know, like, are these versions valid? Probably the B3 version should be valid. That sounds like the last official version that was released. Not sure if hacks are valid, you know? Let's see this one here. Okay, this one, so far so good. Can't wait till I actually implement sound. Been thinking about that. We're getting close to that part, you know? Actually implementing sound. I'm gonna have to start looking into that. Okay, this is the one where I died last time. Let's see if I can get a bit better now. Damn it. Whoa. Oh wow, that's tricky. That one just moved right behind me. Yeah, this game is awesome. Okay, so I beat that level. Because the little turret actually moves really slowly. Ah, shit. Okay, I have like these bombs in reserve that allow me to just blow out everything around me. It's so cool how the level gets smaller. You see how like it shrinks in the corner there, and if I shoot it, it gets bigger. Hey, what's up, ABD? Oh yeah, thanks, man. Yeah, I made some progress. Yeah, so that's it. It spins slowly, and like the amount it spins really relies a lot on how much I tap my analog, which can be a bit difficult sometimes, right? It's really about getting the thresholds. And I mean, I don't know if like, oh, see, look, it got that bug again. And I don't know if like I'm emulating, you know, the analog feel on my controller here, how close it is to the actual analog like distances and everything on the Vectrex itself. So maybe it's actually easier on the Vectrex than it is on my stick, or the opposite. I don't know. So okay, this dot's kind of disconcerting. It seems like when I die, I wonder if it's like pretty much always when I die and try to continue. Yeah, I'll just let myself die. Okay, end. Okay, then I hit, it's like something, go. Yeah, there we go, white dot. Okay, so we're not quite out of the woods there on Bedlam, and I'm guessing this happens with the original version here. So I'm just fast forwarding here. Yeah, same problem. Okay. So this is probably something we can track down by, again, looking at whether we hit that instruction that re-enables or sets the interrupt mask to 0, and seeing, does that happen again when we start on the next round, like, or do we ever hit it, or why? Like right now, I'm guessing. Now see, so interrupt mask, the interrupt mask is set to 0, but maybe it's supposed to be like reset back to 1, or set to 1, I should say, and then remain that way until it's ready to start processing the ISRs again for the game. And that's maybe not happening or something, which would be weird. Let me see, is there anything I can tell from looking at the code that might explain that? Wait a minute, waiting for interrupts. I just had a thought. So I added this, now I have this little state machine in the execute instruction. So execute instruction became slightly more complex than it used to. It used to just say, it just used to execute a single instruction. But ever since we implemented CWAI, we now have this mini state machine that's like, if I'm waiting for interrupts, right? And waiting for interrupts is something that gets set by CWAI. Because this is basically a, wait for any interrupt or something. I forget what it actually stands for. No, and CCR wait for interrupt. So and the CCR register and wait for interrupt. So when we do that, we set this thing to true. Now maybe I need to set this back to false in my reset, because I realize we're not setting it to false when we reset. So that might be all we need to do to fix this. It kind of makes sense even. So here's reset. All right, let's try this. All right, I gotta kill this version that's running. Okay, so let's fast forward and die. Still same issue. Ah, wait a minute. But reset is itself an interrupt. Of course. So yeah, that probably puts us in a state where, could it be? If it's waiting for an interrupt and it receives a reset, that it needs to execute the same code. In other words, if we're in a state where we're waiting for an interrupt and we get a reset, we want this to be true so that we come in here and set back this to 1. Read, I don't know. No, I guess that doesn't really make sense. Because reset is really like resetting everything, including our stack. No, it doesn't make sense. Wait, we're not even resetting, are we? What am I saying? Why am I saying reset? We're not resetting. Or maybe what I'm not, that kind of makes sense. Maybe what I'm not handling is, what happens if we're waiting for an interrupt? No, if we're waiting, we're waiting. There has to be an interrupt that occurs. No, it can't be related to this. So no, we're gonna have to debug this. Having said that though, it is correct for me to reset this variable in here. We do want to make sure it's false when we reset. But that's that's unrelated to what we're looking at here. So there's something else going on in the sequence for when we end the game and we go back to the main menu and we want to press play and we end up with that white dot. And we know that we can repro it by just starting with the interrupt mask at 0. So it may be related to that. Okay. So let's do this. We're gonna say good. And I'm gonna say but after game over, new game doesn't work. White dot. I'm gonna erase this stuff here. Leave it like this. Trying to think how to figure out what's going on here. See, when we have that dot, I just put a breakpoint here. IRQ is enabled. And interrupt mask is 0. So we're doing this push. Setting interrupt mask to 1. We're going to now launch into our RQ handler. Interesting. PC is F1A0. That's a BIOS routine. F1A0? Really? F1A0. Okay, we're in the wait recal. That doesn't make sense. No, I guess it does make sense. Okay, we're just looping somewhere. But while we're looping, RQ is enabled and our interrupt mask is 0. Now we're about to jump to this interrupt vector. So let's see where it brings us. CBF8. Yeah, that makes sense. Okay, so we hit this. Now the next instruction should be a jump. Yeah, jump 09B9. So this is the interrupt service routine that is trying to run. Loads the stack. Okay, so usually if we're loading the stack, it's because we're about to reset. We're starting all over. And then after that, it does a jump subroutine 04BE. Okay, so this is one of those cases where we don't get an RTI, because in any case, if we're resetting the stack pointer, we don't care about the fact that we push the state to the stack. And then it's doing an explicit jump, probably to some routine that kind of like starts the game, and then that jumps to F1AF. Okay, DP to C8, so that's the DP register to C8, sure. RTS, back to 04C1, then it jumps to another subroutine, 0830, and that does F533. Let me load my symbols again. Where are my symbols here? BIOS. Oh, hey, Peas and Rice. Thanks for the subscribe. It's awesome, man. Appreciate it. I think you are my first subscriber. Thanks, man. It's very nice of you. Okay, so now, yeah, see now we're gonna see this. We're like in some routine that does music stuff. So like none of this seems odd. You need to see how far I've come. So you just joined, right? Alright, I'll show you at least something fun. What's a fun game that's worth seeing? You haven't seen this in at least 3 months? Okay, well it's moved forward a little bit in 3 months. So let's see. What's fun? There's a lot of cool games that I've been messing around with. Okay, I think one cool one is Armor Attack. At least you'll see like that the emulator. I think the last time you came. I think the last time you came, you told me you saw me just working on CPU stuff, right? So basically, what you saw me doing just earlier, just today, coming in, like damn it, still debugging CPU stuff. But actually, no, we've got shaders, we've got rendering here, we've got this kind of like glow effect going on there. So then there's this overlay, and like this overlay here, you can like play with it here. There's even like, I can even mess around with the blurs. I can turn off the blur completely, and we just got like lines that are rendering here. And that's with the blur on. I think it's pretty cool with the blur. We've got, we can play around with how much the CRT like kind of fake darkening thing goes on. So you can see here like lots and lots and lots of trails. Or we can go completely the opposite way and have like no trails and just super heavy flicker. I think it's something around here. Feels pretty good. The blur was part of the original code, or is this something you added? No, I added this. I basically I wrote a bunch of shaders to kind of emulate what the CRT would be like. So I draw lines, and then I draw them to a texture, and then I feed back that texture back. Like I don't clear it, so whatever lines were drawn remain there. But then I have this shader that just brings all the values, like it's a pixel shader, that brings all the values down to 0 over time. So it's like basically, you know, slowly clearing the screen, sort of trying to emulate how the phosphors, you know, go to black on a real CRT. And so you actually get this kind of flickering effect because of that, which is kind of cool, just like a real CRT. And then the glow is something that I added after. So yeah, it's kind of cool, and what was fun about this was that it was really like my first foray really into doing shaders, and it's like a kind of like a nice way to be introduced to writing shaders. It's not too complicated, you know, not dealing with like lots of colors and stuff like that. It's nice and simple. So it's a lot of fun. Yeah, thanks, man. Really appreciate it. So this is this one. Another fun one that's really cool to watch is there's one called Dark Tower. I like showing this one because I think it's surprising to a lot of people to see. Yeah, I'll just keep it small because frame rates. This one surprised a lot of people because usually when you see like these vector-based games, they're typically like you know, a tank or a spaceship, but you rarely see a dude walking inside a forest like this. You know what I mean? So there's like a guy that like walks in a forest, and you're like looking for these treasure boxes. Let's see if I can find one. I don't know why those bags disappear. Your score is 200. 5 reserves, troops, 4 bags of gold. Okay. I'll show you, like, at some point we'll actually find... Damn it. These bags of gold keep disappearing on me. I like this song. There we go. Nothing? Okay, I guess that one's empty. Look, nice remix. Hey look, different trees. I don't think I've ever seen these trees. Here, let's zoom through. Oh, I reached the end of the world. Oh, I know we're back. I think this is a looping world. Is that possible? So it says at the top there, south, southeast. Whoa! And I think I just got teleported. 1 bags of gold. I just wanted to show you, there's actually these kind of caves you go in where you fight these bad dudes that look like demons. The original Slender Man. Let's see here. Oh, here we go. Okay, so I don't know why I get these asserts here that. But anyways, look. And then you like shoot. You have this guy who's like shooting stuff at you. You try to hit him. Ah! And I got hit. Pretty cool, right? That's a pretty cool game. There was another game I was playing recently that was really a pretty next gen. In 1982 or 1983. That's crazy, crazy old, right? I think it's this one, Vectrex. So this is actually a game that was made, it's not an official release, it was made in 2002. And so it's made by it's a home brewer. And I find this game really awesome. Like I was playing this not too long ago and I was finding it really fun. So like you're this little ship and you have these planets. Oh, see, and I get sucked into the middle there. And I go on this planet and whoops. Okay, go back on. And then, see there's like this guy here, whoops, okay, you can shoot, and it's really cool to control, and you gotta like save these guys here. So I saved one, go to this, whoa, and I gotta get fuel, so this F here is a fuel tank. Okay, go in here, whoa, okay, get this fuel tank. This is really hard because like basically you're always being the control is really cool. Like there's like gravity. See, I'm getting pulled down by gravity if I don't use my thruster. But using my thruster, it uses fuel, and I just smashed. Yeah, so I think this game is like inspired by there's a game like Lunar Lander, I think it's called. It's a classic game where you're trying to land a ship on a planet. I don't know if this game is actually. Yeah, that's okay. Lunar Lander, yeah. So it's got a Lunar Lander feel to it, but it's like a combination of Lunar Lander and a whole bunch of other games. It's really fun. It's really the play control that makes this game fun. Yeah, or asteroids, like any of these kind of games where you shoot. But because of the gravity thing, hence I guess the name Vectrex, it's really challenging. Like, I've practiced, so maybe it doesn't look so hard, but man, it's hard. You gotta kind of like turn yourself away from where you wanna go. Like if I want to go left, see, I gotta use my thruster to move myself away and not go too fast in one direction, or I'll smash into a wall. Okay, so let's say I'm done with this planet, right? So we go to this one here, this eyeball here. So this is a planet, and actually what's cool about this one is that the gravity is pulling me towards the center of this, this planet. So like, see, when I'm under here, oh, okay, I'm under here, I'm being pulled to the planet this way now. So it's really interesting because like now you got to change your strategy for picking up these guys and saving them. Oh, it's really weird. Okay, I got one. Okay, let me get that fuel cell. Ah, and I got shot. Yeah, no load times. Yeah, man, it's powered by an incredibly powerful chip. 1.5 megahertz. Yo, that's 1.5 million instructions per second. That's like super impressive. Okay, so I saved everyone from here. Whoa, 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 whoa. Okay, how do I leave this planet now? Okay, I have to go up. Okay, now we go to this thing here, this swirly thing. And I just got shot. I think I just died. But how cool is this game? Vectrex. And you bounce off the wall, off the edges of this universe here. And like, you're not safe even in this screen here. So basically, I think what we're supposed to understand, this is like some kind of solar system. That's like a sun in the middle. Why not try this? Look at this. Okay, so in here, it looks like we don't have... What's the gravity rules here? Looks like gravity is not pulling us here, so you just got to be really, really careful. Oh, and I just lost. I want to go back. Okay, let's just do this. Okay, nope. Let's make it to that ship thing. So, what am I adding to the emulator? So I'm still like trying to get a whole bunch of games that are not working, and that's what I've been doing for the last little while and succeeding. I'm going through this compatibility list that I put together of ROMs. A lot of them are working, a lot of them are not. Some of them work and then don't work afterwards. And so it's basically trying to debug those. And in terms of like major features, apart from like compatibility and getting things to work, there's audio. I gotta get sound working. So that's gonna be fun. That's so sensitive. So it looks like I have a timer on that screen. See, it says escape time in the corner. So I think it's just about, can I do this fast enough without dying? And I don't think I can. Oh boy. Maybe I should try another one. Whoa, what's this view? Seriously though, quite cool this game. Like really one of the most advanced games I've seen. So that's by this John Donzilla guy. So yeah, kudos to this guy for making a really cool game. Yes, unforgiving, but that's true of like a lot of old games, right? And I don't mind, you know, super challenging, hard games. It's part of the point, I think. I wonder if John Donzilla made other games, at least that are in my list. Oh, it's with one. Okay. Zoa. Oh, he made quite a lot of games actually. Just curious. Let's try all the good things. See, for this one I even have an overlay. I'm sure the audios must be good on this game too. These games are just really high quality. So this is 1996. It's probably like early days for him hacking on the Vectrex. Press button 4 to select a game. Oh, I think this is one where you can, yeah, choose different games. So you've got one called Rockoroids, which is like an Asteroids clone. You have an Invaders-like game. You have Vectress, which is a Tetris game. Spike's Water Balloons. Like if we try this one here. So I guess this is oh yeah, that's it. And this is a game where turning isn't done with the analog, it's done with the digital, which I think is supposed to emulate like the original. So I have to kind of put my two fingers like this. I find it really hard to play. Especially on like a 360 gamepad. Maybe if I had the 4 buttons horizontally across like on the real Vectrex, this game would be a bit easier to play. It's nice not seeing loot crates in the game. I'm glad we live in the future and don't have controls like that anymore. No, but this, yeah. So this was actually quite ahead of its time because it had an analog controller on it, and most games use it. This game purposely is not using it though. You can't handle GoldenEye? Oh right, on N64. Yeah, the fact that it's not dual, kind of like a dual analog for moving and aiming. Yeah, let's try this Invaders one. I don't think I tried this one. Oh no, I did try it. Okay, and same deal here. You got to use the 2 buttons to move and get destroyed. Man, the fire rate is awful. You can only shoot 1 missile at a time. Yeah, so GoldenEye definitely has interesting controls. In fact, I don't know if Raptor is still watching, but I know he actually really loves the controls of GoldenEye. And you know, for its time, it was definitely revolutionary. Okay, let's try the Tetris game. Yeah, so You know, there's maybe a bug with my rendering here, like the lines being drawn that way. You can see there's definitely an offset. You know, I can't go more left than this. So if the lines were being drawn correctly, things would line up. And they probably do on the real Vectrex, but there's something going on with mine, I would surmise. But definitely playable. Square, square. Great. Awesome. And there's my line. And then the final game is a Spike's water balloon. Where am I supposed to catch? I guess I'm supposed to catch the water balloons? Get ready for level 2. I bet you there's digitized speech here. I wonder what this kick move is for. Start select. Holy crap. Shit just got real. Level 3 turned it up a notch, eh? Oh no. Okay. Ah! Oh no indeed. Alright, so, you know what guys, I'm going to stop here, but, peas and rice, thanks again, guys, thanks for watching, and that's it, that's going to be it for this week. I'm probably going to be back next Monday as usual, so, or, actually, yeah, I'm not sure about next Monday, we'll see, so, I guess just going to play by ear, but, anyway, if not next Monday, definitely back next Wednesday. So guys, thanks again for watching, and I hope to catch you next time.